Hi everyone. In this video, we're going to talk about an introduction to enzymes. Enzymes are biological catalysts. Okay, and they're made of protein. Now, first off, let's just define what a catalyst is. A catalyst is a substance that speeds up a reaction, but is not consumed by the reaction. So the catalyst is actually recycled and can speed up another reaction, and so on and so forth. So proteins, our enzyme catalysts, are what help to speed up the biochemical reactions that occur in our bodies. If we didn't have enzymes, we might be waiting, years or 100 years even for certain reactions to occur. In order for living organisms to sort of live in a normal lifespan, we couldn't wait that long. So enzymes have evolved to help speed up the numerous biological reactions that occur. All right, so a couple things about enzymes, a couple other definitions that I need to give. There are two types. Okay, there's a simple enzyme, and then there's a conjugated enzyme. Conjugated. A simple enzyme is just a polypeptide chain. Okay, or it can actually have multiple polypeptide chains. So it could have either tertiary or quaternary structure, but it's just going to be protein. A conjugated enzyme contains not only polypeptide, but also a cofactor. Okay, so previous example we looked at was hemoglobin. That's actually an oxygen transport protein. It's technically not an enzyme, but that heme group would be considered a cofactor. It's not actually made of polypeptide. Another couple of definitions related to the conjugated component here. A cofactor, let's just define that. That's a non-protein part of an enzyme. And we'll see throughout the semester a lot of examples of cofactors. The other definition, apoenzyme. Apo means without, so this is the enzyme without the cofactor. And in general, apoenzymes typically are not going to be active. They're not going to be able to do the catalysis. So when we talk about enzymes, and you've heard me use this term before, activity. So enzyme activity, let's just define that. Okay, enzyme activity is essentially the ability to catalyze a reaction at a specific rate. So when enzymes are described as being fully active, that means that they can catalyze their particular reaction at its maximal rate. However, if an enzyme, let's say it was a conjugated enzyme, if it was, say, missing the key cofactor that was needed in order to be a catalyst, that enzyme would have essentially no activity. So when you hear that phrase, activity in relation to enzymes, it simply means the ability to actually catalyze the reaction. So in our discussion of enzymes, I need to first talk about the part of a protein catalyst that is actually going to be doing the catalysis. That's often referred to as what's called the active site. Now, I've drawn here sort of a schematic protein. It might remind you of a famous video game from back when I was a kid, Pac-Man, if I put a little eyeball there. This is actually Miss Pac-Man, if you put a little bow on there. Anyway, this looks kind of like a mouth, right? So the active site of a protein is where a substrate could bind. All right, so if I had a molecule, let's say, that looked kind of similar in shape, and I'm going to call that S for substrate. Let's put E over here for enzyme. The enzyme can bind a particular substrate, or sometimes certain related compounds that would be considered substrates, and oftentimes they will have a very similar shape to what's called the active site. And the active site is usually a cleft or maybe a region of the protein, often an embedment or some part of the protein that's not just on the surface, but a component that could actually bind something. And the active site is going to be made up of side chains. of different amino acid side chains, carboxylic acid groups, amino groups, hydrogen bonding groups, cysteines, various things like that, that would then have some sort of attractive nature that matches up with the substrate. Okay, and in doing so, we can now form, in a reversible way, what's called the enzyme substrate complex. There's our enzyme, here's our substrate. This is called the E.S, or enzyme substrate complex. It's often written like that, E.S with brackets around it. So in order for the substrate to ultimately react or do some sort of chemistry, it's going to need to bind to the active site of the enzyme. And again, it's these side chains that are three-dimensionally positioned in exactly a certain way, because this is a fully folded three-dimensional protein structure. It's going to match up with various groups on the substrate that have attractive groups on them and form this non-covalent, that's an important point here, these attractive forces are non-covalent and forms in the enzyme substrate complex. So notice this is a reversible reaction, could go either way. But once the substrate is now bound, the side chains that are sort of surrounding the substrate now are perfectly positioned in three-dimensional space to now catalyze some chemical reaction. So that's what an active site is. We can draw this out a little bit simpler way if we just say E plus S yields E dot S. Okay, and that intermediate now is usually a very short-lived intermediate that's now going to convert to enzyme dot product. And then that continues to enzyme plus product. And notice the enzyme, since it's a catalyst, is going to be able to recycle and bind another substrate, go through the same process, and so on. So I haven't drawn it here. We'll see this a little later. But if I convert this substrate now to a product, I would get E dot P. The actual chemistry step is happening right here. That's where the substrate's getting converted to product. One important note that I'll finish off with this part is that all of these are reversible interactions. So the binding of substrate to make the E.S, the conversion to the E.P product complex, and then finally here, these are all reversible processes. But just to give you an idea, so let's say a reaction S going to P, okay? Let's say that reaction happens over the course of, say, if you didn't have any catalyst, maybe took, I don't know, 3 days. Okay, a typical enzyme catalyst, they're going to catalyze this reaction in a much, much shorter amount of time, on the order of milliseconds, microseconds, and sometimes even nanoseconds. So we're talking, 10 to the minus 9 seconds. So enzymes are extremely powerful catalysts that can speed up reactions to allow them to occur in a time frame that organisms like us can actually use in our lifespan. All right, so that sort of wraps up the basics of enzymes and what an enzyme active site might look like.